In this video, we're going to discuss the first application of integration, which is finding the area under the curve. So the formula for the area is equal to be the integral of y dx from a to b, or the integral of f of x dx from a to b. So the y and f of x are just the same. So let's try to have an example number 1. Let's say that I have here my Cartesian plane, and this one here is my line. Y is equal to, let's say y is equal to 3. And then I want to find the area from 1 to 4. So I want to find the area of the shaded region. So basically by using the elementary mathematics, you can see that this is a rectangle. And we know that the area of that rectangle is 3 units here. So that is 3, the base times the height. The height is also 3, which is equal to 9 square units. However, let's try to test our solution. Let's try to test this formula whether this one will give us the same answer as 9. So it says the area is equal to the integral of y dx, but your y is equal to 3. So the integral of 3 with respect to x from 1 to 4. Alright? Again, we're just testing the formula whether it's correct. If the answer is 9, therefore the formula, meaning this formula, is actually correct. So you have there the integral of 3 is 3x from 1 to 4. So that is now the area. So the area now is equal to 3 times 4, you plug it in, minus 3 times 1, which is equal to 12 minus 1, which is equal to 9. So therefore, the formula really works in finding the area. Let's say, for example, I have the second example. I have my Cartesian plane. And let's say that this is my line. Y is equal to x. And let's say that I would like to find the area from 0 to, let's say, 5. So we know that the area of this shaded region, the area of that region R, is equal to 1/2 the base times the height. But what is your base? Your base is 5. And if x is equal to 5, your y is equal to 5. So therefore the height is also equal to 5. So 5 times 5, 25 divided by 2 is 12.5. So let's try to test our formula whether this one whether we can get the same answer. So that is the integral of, the formula is y, the integral of the x from 0 to 5. So therefore the area now is equal to, your y is equal to x, the integral of x dx from 0 to 5. So the integral of that is x squared from 0 to, x squared over 2 from 0 to 5. So therefore, this is now equal to 25 over 2 minus 0, which is equal to 25 over 2, or 12.5, which is actually equal to our answer. So therefore, it's really correct. It's really correct that the area under the curve is given by this. So again, that is this area, the area under this graph here, under this line. So let's try to have one more example. Suppose that I have, okay, so let's try to have more example here. Suppose that I would like to find the area. My curve is y is equal to 2x to the 4th, and I would like to find the shaded region from x equals 1 to x equals 3. Well, just for us to visualize this, you don't need actually to sketch the graph of this, but for you to be able to visualize, so the graph of this one looks like this, right? And then if x is 1, so this is 1, and then you have the relative, for example, that is 3, and this is what we're looking for, that shaded region. And how shall we find the shaded region? We say that the area is equal to the integral of 2x to the fourth with respect to x from 1 to 3. So the area now after. So let's integrate this. Integrating that we have 2x to the fifth over fifth, and then from 1 to 3. So the area is equal to, you plug in the 3 there. So we can just simply factor out 2 to the fifth first. 2 to the fifth, 3 raised to the fifth minus 1 to the fifth. And that region will give you 484 over 5, right? So let's try to have next example. Suppose that you have your y is equal to cosine x minus sine x, and you would like to find the area. You would like to find the area of the shaded region from 0 to pi over 4. So from x is 0 to x is equal to pi over 4. Right? So what are we going to do? This one we don't need to draw the graph. Okay, to draw the graph of this is a bit complicated. So let us just try to find the area right away. So that area is equal to the integral of cosine x dx minus the integral of sine x dx, and that is from 0 to pi over 4, from 0 to pi over 4. Alright, so the integral of cosine x is sine x, and that is from 0 to pi over 4, minus the integral of sine x is negative cosine x, so that's going to be plus cosine x there, and that is from 0 to pi over 4. So what we're going to do is to plot in sine pi over 4 minus sine 0, 0, plus cosine pi over 4 minus cosine of 0. Sine pi over 4 is the square root of 2 over 2. Sine of 0 is equal to 0. Plus cosine pi over 4 is the square root of 2 over 2. Minus cosine of 0 is minus 1. So this one gives you now. Let's write our answer in terms of series. This one I will give you 2 square root of 2 over 2, or square root of 2 minus 1. So this is our answer. We still have 2 minutes, so let's try to get one more example. Suppose that my y is equal to 1 plus e to the x minus 1. And we're looking for the area of the region from 1 to 2. From x equals 1 to x equals 2. Again, the area is given to be by the integral of 1 plus e to the x minus 1 dx from 1 to 2. So let's integrate this one by 1. The integral of 1 is x, plus the integral of this one is e to the x minus 1, and then just simply plug in from 1 to 2. So therefore you have your 2 plus e raised to 2 minus 1 minus 1 minus e to the 1 minus 1 is 0. And what is that one? That is 2 plus e minus 1. So this is minus 1 as well. So that is minus 2 plus 2 is 0. So that's equal to e. Right? So therefore this region is equal to e, or approximately 2.78. Okay, on the next video I'll give you more examples on how to find the area under the curve using integration.